Very good morning. Today we are going to solve a simple circuit, and here we are going to find out the unknown current in the each element as shown in the figure. Sometimes in 5 mark question they may ask this kind of question. Very simple. You can solve in within 5 minutes if you got this type of question. So first you understand the question. So here 25 volt is there. So here the current is IT, and this IT is dividing into two currents, that is IA and IB, and again it is further dividing into IC and IF. Okay, and further dividing into ID and IE. Okay, we need to find out all these unknown currents. Unknown currents are IT, IA, IB, IC, ID, IE, and IF. So this is the problem. Okay, so for that, first we need to reduce all the circuit. First, we need to find out what. Here, if you see, this is the circuit. This is IT, IA, IB. So here, IC, IF. Okay, here ID and IE. Now what we are doing is we are further reducing the circuit. Here 2 ohms and 4 ohms are in okay. So this 2 ohms and 4 ohms, and this 4 ohms and 4 ohms are in parallel. So that we are reducing to 2 ohms, because same resistance means if it is in parallel means 4 divided by 2. So that we are converting into 2 ohms. So again this 4 ohms comes. So here this also in the parallel connection, 3 ohm and 6 ohms and 3 ohms. So 6 into 3 divided by 6 plus 3. If you reduce, it will becomes 2 ohms again. Here we are adding. So now further reducing this circuit, because this 2 and 4 ohms are in series, so 6 ohms. So 2 plus 4 is 6 ohms. And again this 2 and 4 ohms are in series. Again 2 plus 4 is 6 ohms. So this again further reducing, this 6 and 6 ohms are in parallel. So two same resistance are in parallel. Then what we need to do is that particular one resistance divided by 2. So 6 divided by 2 is 3 ohms. Again this 2 ohms as it is will come. So again further reducing, this 3 ohms and 2 ohms are in series. So 3 plus 2 is 5. So here we are going to find out what is IT. So IT is equal to 25 divided by this 3 plus 2 is 5 ohms. That is 5 amperes. Okay, so I is equal to V by R, or V is equal to IR. That format IT is equal to 5 amperes. So IT we found out that is 5 amperes. So this current IT is 5 amperes. So that is further dividing into 2. Now IT we found out. So IT is equal to IA plus IB. Can we write like this? Because this IT is equal to this IA plus IB. So IT is equal to IA plus IB. So now by using the current division rule here. So what is the current division rule? So say for example, IA, if you want to find out opposite resistance is 3 ohms divided by this two total resistance, that is 3 plus 6. Okay, this total resistance into this current. Okay, that will give you the IA. Similarly, if you want to find out IB, so first we will solve IA. So IA is nothing but opposite resistance. So here opposite resistance is what? 3 ohms. Okay, for this IA opposite resistance is 3 ohms. For this 6 ohm opposite resistance 3 ohms. So 3 divided by 3 plus 6 okay, into this IT, that is 5 amperes. Okay, that we calculated. So that if you found out, you can find out IA. So what is IA now? So IA is equal to 3 divided by 6 plus 3 is 9 ohms into 5 amperes. So that will gives you the, if you further simplify, it will give you the current as, that is the current division rule. Okay, so opposite resistance divided by the total resistance into the current, okay, of that particular branch. So 1.67 amperes. Similarly, IB. So IB again, no need to find out by current division rule. You can also find out, but here itself we can easily find out, because IT is equal to IA plus IB. So IB is equal to IT minus IA. So IT minus IA is nothing but what is IT? So IT is 5 minus 1.67 is IT is 5 minus 1.67 is 3.33 amperes. Like that also you can find out, or otherwise no, I need to find out by using current division rule also, you can do it. Now can we do? We can try and see. So here you see what is IB. So IB is nothing but the current flowing in this particular 3 ohm resistance. So Opposite resistance. What is opposite resistance? 6 ohms. 6 divided by 6 plus 3. Total resistance. 6 divided by 6 plus 3 is 9 into 5 amperes. So if you further simplify, you will get a 3.33 amperes. So you just tell in the comment whether by using the current division rule, you got the same IB value or not. So now we found out IA and IB. Clearly, we found out what is IA and IB. Now, next thing we need to find out, after finding out IA and IB, next we need to find out what is IC and IF. IC and IF. So what we are doing is, so here we are taking some notations, some values, say I total, like that we are taking, or otherwise you can take some values, IAB. You can take here as a IAB. Okay, so here they mentioned wrong. Here IAB, like that you mentioned. So IAB is equal to IC plus IF. Like that also you can do. So here IAB is equal to A plus IB. Like that also. So here, sorry, here. So IAB is equal to IC plus IF. So here also what we are doing is this current is equal to this particular current is equal to this current plus this current. So what we are doing is we need to find out IC and IF, same current division rule. Okay, so current division rule. So for example, if you want to find out this IC means opposite resistance divided by total resistance into the current in this particular okay, this particular thing. So opposite resistance, what is opposite resistance? Here the opposite resistance is 6 ohms divided by this total resistance. What is this total resistance? Total resistance is 6 plus 6, that is 12 into this current. This current is again 5 amperes. Okay, so that 5 amperes we are adding over here. So IC is equal to this opposite resistance. What is opposite resistance 6 uh, divided by 6 plus 6, 12 into this total current. Okay, so that is 5. So if you further simplify, you will get IC as 2.5 amperes. So again from this, so if IT is 5, so IC plus IF, if if IT, so why here IT we are taking now? So in the series connection, the current is same. Okay, so current is same. Okay, so voltage is different. In parallel connection, voltage is same and current is different. Okay, so that's why this current will come here, because this current is dividing into two, and again the same current is coming. So okay, so that's why we are taking the IT here. So here IC we calculate, that is 2.5 amps. So here IT or IAB is equal to IC plus IF. So IC plus IF means, so here easily you can find out, because IC you know, so IF you can find out. So IT minus IC is nothing but IF. So IF is equal to 2.5 amperes, or otherwise, no, I am going to find out with the same current division rule also. Well and good. So next we'll calculate that also. So IF is equal to opposite resistance is what? IF is equal to. So what is the this resistance? We need to find out the current. Okay, this is nothing but IF. Okay, this is nothing but IF. How to find out this IF? Opposite resistance is 6. So 6 divided by total resistance, 6 plus 6. Okay, 6 plus 6, 6 plus 6 into, okay, into the current. Total current is nothing but 5. Okay, this is the 5. So 6 divided by 6 plus 6 is so again it will if you solve this with scientific calculator, it will give you 2.5 amperes. So just we verify, okay, IF is 2.5 amperes, so that only we got it as here. Or otherwise, simply by this equation also you can find. Okay, just to verify the answer, you can do like this also. Next, now we found out what is IC and IF. Now IC is further divided into two, that is ID and IE. Okay, so now we need to find out what is ID and IE. How to find out ID? Yeah, here you see. Um, Yeah, IF also we found out, that is 5 minus 2.5 is 2.5. So IC is equal to ID plus IE. Okay. So ID, how to find out ID? ID is nothing but opposite resistance. What is opposite resistance? 4 ohms divided by total resistance 4 plus 4. Okay. Into the current IC. What is the current here? IC, what is the current year IC is, we already calculated 2.5. So into 2.5 amperes, so that will give you 1.25 amperes. Okay. So similarly, you can find out by using this ID you found out IC, IC is nothing but 2.5 amperes. Okay. ID is nothing but 1.25 amperes. So if you calculate I is equal to IC minus ID, again you will get IE as 1.25 only. But here, just for your understanding, again I verified using the current division rule. So let's calculate what is IE. How to find out IE? Opposite resistance. So IE means current across this 4 ohm resistance. So opposite resistance is 4 ohms. So 4 divided by total resistance is 4 plus 4. Okay, divided by 4 plus 4 into this current, this IC current. IC current is 2.5. Okay, so that's what we did. 4 divided by 4 plus 4 into 2.5. That will give you 1.25. Either way you can calculate. So now we calculated IE. Okay, so now we calculated all. IF also you calculated, right? IF also we calculated, ID and IE. So finally, you need to take out all the values and write what is IT. So IT is 5 amperes, IE is equal to 1.67 amperes, IB is equal to 3.33 amperes. Next, IC is equal to 2.5 amperes, IF is equal to 2.5 amperes. Next, ID is equal to 1.25 amperes. E is equal to 1.25 amperes. So these are the final results. Next, like that, all answers you need to write. Very simple problem. Just I explained in detail. If you solve, hardly it will not take more than 5 minutes to solve this problem for this 5 mark question. But this units are very, very important. Amperes, don't miss this amperes and ohms wherever required. Okay, so that units you need to take care of after completing the problem. Once you check what is the equivalent resistance, what is the total current, what is the current across, because they in the question they simply ask what is the unknown current through each element. So unknown current is what they mentioned. So that we all we found out for this particular